Electricity, the steam engine, the automobile, the computer, the internet. These are a few of the innovations that shifted entire civilizations, and now we're entering a new era, a race that promises to revolutionize our world with incredible new advancements. Welcome to Quantum State.
I think quantum computing and quantum technologies in general are an opportunity for us to advance the capabilities that we have as a species and push the information age forward.
Those are the technologies we will use to revolutionize our society, how we deliver medicine, how do we monitor people's health, how do we monitor the health of the earth.
We're staring at some of the foundational pieces of science.
Quantum State. It conjures up images we've seen in the movies and TV. But this is not science fiction. It's reality, and it's happening now, right here in Colorado.
Quantum is how the universe really works. It's how particles really interact with one another. It's not intuitive to humankind, but it will be. Your kids or grandkids, when they get to kindergarten, they're going to start learning about quantum early on. It's our ability to master the true physics of the world and create that into useful services and products that will make the world a better place.
Quantum is a new kind of computing or sensing science at the subatomic level, much the same way nature works.
Yeah, so these two are two master lasers.
Scientists have been working to harness it for several decades, but now we're entering the second quantum revolution, where science begins using what it learned to create.
So the first quantum revolution was when people figured out what quantum is, and that has led to the information technology revolution, and that has led to computers, that has led to MRI scans, that has basically changed our world as we know it. Now the second quantum revolution that everybody is talking about is based on entanglement, where we do not just kind of know that quantum is there and use it, but we are able to actively manipulate it.
Quantum technologies are at an exciting junction where they're moving out of the university laboratory into the engineering workshop and into industry.
Imagine eradicating diseases quickly after they appear, reversing climate change, long-lasting batteries for self-driving vehicles, the ability to predict earthquakes and create superconductive materials for space travel, even teleportation. While Apple has coined the term think different, these quantum systems really do.
So the first piece is this kind of what we call quantum information, where instead of ones and zeros, you have things between 1 and 0, or 1 and 0 like black and white, true and false, gay and straight, whatever analogy you'd like to use. And so in between those extremes, you can think about this sitting on a sphere of possibilities. This is what we call the quantum bit or qubit.
For example, to solve this maze, today's classical computer will explore a single path at a time to find a solution. The quantum computer, however, will try all paths simultaneously to arrive at the answer, making it exponentially more powerful.
Quantum computing has a way of being able to check all of these outcomes at the same exact time. And by checking all of those outcomes at the same exact time, it can open up a computational space that you would otherwise never have been able to.
At groundbreaking labs and industries along Colorado's Front Range, experts are perfecting different ways of reaching quantum state through lasers or cooling to below deep space temperatures.
And just to emphasize how cold we're really getting, this system right here has our sample below 10 millikelvin, which is significantly colder than outer space. And so that's just an incredible engineering feat where we as engineers and scientists and physicists have kind of beat nature and getting colder than something even like outer space.
To reach quantum state, experts agree there are two mysterious forces at work. The first is superposition, the reality that something can and does exist in two states at once. In 1935, Dr. Erwin Schrödinger's famous thought experiment examined this paradox by placing a hypothetical cat in a box along with a device that may or may not kill the cat. Then he asked, is the cat dead or alive? At this point in the experiment, it's both.
I think Schrödinger illustrated very well with his thought experiment with his cat. Quantum mechanically, his cat could be both dead and alive at the same time. And until you look at it, you wouldn't know what happens.
But in quantum physics, we deal with this concept of superposition, where two different states can exist simultaneously.
So superposition is another fundamental property that with engineering we can harness and build into real devices that do things that you can't do in the conventional world.
The second mysterious force is entanglement.
Then there's this idea of entanglement. So you can have two of these quantum bits and you can put them together. Even if you move them separate in physical distance, separate in time, they maintain information about each other.
Basically, you can entangle two particles and move them to two distant locations. And because of that entanglement, they can actually know about what's happening to each other. So I can do something with one of the particles on one end of the universe, and the other particle will somehow know about it.
Quantum entanglement is very fragile, and in fact, quantum computer relies on quantum entanglement, relies on these particles that can have a joint operations, but it's very easily destroyed.
Now, Schrödinger said entanglement is, the essence of quantum mechanics, and I'm paraphrasing in here. So you probably know what your partner or your children are doing right now. You have a kind of sense of where they are, what they're doing, and that's because you're not disconnected. We call that mutual information. So something in your thoughts are connected to something in their thoughts, and it seems sort of spiritual or mysterious or magical or whatever word you like to use for it, but actually it's very practical. It's something we can quantify mathematically. Twins are kind of in sync, right? One sort of knows about what the other's doing, and that's a classical mutual information. So imagine a quantum computer does that, but much more.
What quantum computing can bring is really just exponential steps forward in processing speed. It's the way that we think. We don't think in a binary way. In effect, our brains are quantum. What it does mean is it's a step towards that kind of more creative, free thinking as opposed to just zeros and ones.
As we explore how our lives will be touched by quantum in the next few years, there's a surprising confluence of new industry and some of the world's top scientists coming together.
There are decades of building up in Colorado around this. So we have the Aspen Center for Physics, we have the National Institute of Standards and Technology, we have the National Renewable Energy Lab, we have Mines, we have Colorado State, we have CU Boulder.
So Colorado has a deep history in quantum. There's been a lot of the most important discoveries of quantum that happened right here in our backyard through a combination of the National Institute of Standards and Technology, or NIST, working with the University of Colorado on a joint venture called GILA, has been kind of the intersection of those two.
My students and I built the world's most precise atomic clocks right here in Boulder, Colorado. 50+ years of existence have trained generations of leading scientists now working in industry, in national labs, at university, in academia. Colorado in physics area, in that area alone, we have 4 Nobel Prize winners in quantum science.
We are pushing the frontier of science, but the way we do science, the way to do science is a collaborative way.
Instead of Silicon Valley, you have the Quantum Front Range. This could be one of the forefront places, not just in the country, but in the world, for where quantum computing is done.
Quantum covers a broad range of technologies that we think can affect people's everyday lives. These are things that range from sensors that improve the picture we see and that our aircraft and ships and other platforms see of the world around them. Communications that enable our platforms to talk to each other and talk to the ground, and computation that lets us solve problems we never could solve before.
Is it possible we may be able to eradicate genetic disorders, or even stop the spread of a devastating virus?
One of the ones that just gives me kicks is how we actually develop life-saving drugs today. I mean, we just went through a pandemic. We understand how critical it was for us to be able to get a vaccine out. And one of the things that we aspire to with quantum computing is you will be able to model and simulate these molecules before you ever build it. You know, think about designing life-saving drugs that not only affect humanity but can affect individual people because they're tailored to that person's need.
At Anschutz Medical Campus in Aurora, Colorado, lives one of the world's largest clinical biobanks. A single drop of your blood can be taken and broken down into a massive molecular database called a genome sequence on a chip.
So every chip that I have scanned should have all of that information.
A quantum computer then takes your millions of unique data points and compares them to every other available sequence on the planet to arrive at health probabilities far more accurate than general medicine can provide today.
So 20 years from now, every single patient who walks through the door will have their genome sequenced, and physicians will be much better armed to mitigate onset of disease. We collect and consider as much information and data about each individual patient as possible to make an individualized decision about that patient. So what's your risk of developing a certain disease? How are you going to respond to a medication that I'm getting ready to prescribe to you? To do all of this, we need big data. What's exciting about quantum computing is that it's moving that space forward at an unprecedented clip.
Imagine long-term weather forecasting that would allow you to plan a perfect ski trip weeks in advance, or avoid dangerous storms.
This is the heart of the quantum computer we're building. This is called a quantum processing unit, QPU, similar to the CPU, central processing unit in your computer.
Cold Quanta in Boulder, Colorado is designing and building ultra-cool laser-based systems that may someday soon power a broad spectrum of new advancements.
When you make atoms very, very, very cold, they can pick up signals that you otherwise can't pick up. And those signals will be used for things like discovering kind of mineral deposits that are buried deep in the earth, or being able to sense weather patterns or sense natural disasters such as earthquakes.
Once invisible forces will soon become visible.
Imagine, I'm really worried about Yellowstone, that there's a volcano building up underneath and it's going to explode. We would love to have clock networks around us and being able to actually see how the mass is moving under the ground, to use this to see how the sea level is changing, to see where the ice caps are melting, and so on. And because time and space, gravity, they're all one intricate, same physical quantity, building the best atomic clock based on quantum technology allow us to monitor the environment that we live in.
Giants like Intel, IBM, and Google have been locked in a global arms race of sorts to claim quantum supremacy.
I'm using Google's quantum computer, which has outcomputed all computers on Earth as of, I believe, October 2019.
What you're going to see here at Coquana is a computer that promises to be just as powerful or more so, but you're going to see it in its first version on a big tabletop. And you're going to walk in there and you're not going to be cold because it operates at room temperature.
Then along came Honeywell.
We very intentionally did this as secretly as we could to build up this capability so that by the time we could show the world that we were in quantum computing, we could show the world that we were also the best in quantum computing. How do we truly pay attention to everything? How do we take into account the dynamics that are going on in the weather to figure out how we reroute aircraft? We reroute aircraft today. We do that incredibly suboptimally, in a position where you're starting to have access to all that data, but also you have a processing power to say, this is the right answer now. That's a pretty powerful moment.
At Lockheed Martin, communications and logistics are top priorities.
You may have two aircraft that communicate with each other. You may have an aircraft communicating with a base station, who's communicating with a soldier in the field, who's communicating with a satellite that allows them to access information about where our various platforms are, where they can get help, what information can be passed to them about their situation that might make the difference to them and give them the tactical advantage. We want this information to be secure. We want it to be thorough. So we want things that are covert, secure communications, but with high bandwidth that will allow us to send more information and give more advantage to our people in the field.
It sounds incredible, yet as Einstein predicted, nature itself has been functioning on the quantum level since the beginning of time. How? Just ask the humpback whales off the California coast.
How do whales know how to get from Alaska to Mexico? How do they navigate? What is happening inside of that whale that allows them to know, how to traverse, that adventure? It's got to be some kind of quantum sensing, the same kind of sensing we're beginning to build, where at the subatomic level, they could sense the environment in ways that they can navigate a real complex environment, presumably without even thinking about it the same way perhaps humans think.
In theory, we could rely on whale navigation to get us to our destination.
In order to make autonomous driving truly autonomous is quantum sensing. The vehicle is able to know exactly where it is, exactly how fast it's going, without needing to be in communication with GPS systems.
And from the streets, quantum will also take us to the stars.
Quantum sensors include gravity measurement devices, and these gravimeters are key to deep space navigation.
Spacecraft that's able to keep track of exactly where it is as it goes deeper into space and be able to stay in some level of communication back here without getting lost in space.
And what about what's in your wallet? While global leaders know that quantum may help solve some of our world's most complex problems, at home, you'll be able to more accurately model your savings portfolio to plan for retirement.
And if you think about, well, what a big financial services company going to go do? They're thinking about problems like fraud detection, or think about cybersecurity, right? Protecting your financial resources, your pensions, your nest egg. These are things that you want them to care about. You want them to be forward-looking, to be able to say, how do we use quantum computing to help protect?
We've seen all the threats. We've seen every single person has received a notice that something's been compromised.
What will happen? Will our whole secure internet banking infrastructure come crumbling down if a quantum computer cracks the factoring problem? Well, the answer is no. The answer is we just have to make better encryption and solve our problems in more advanced ways.
There are going to be those companies who look and say, is this a predictive tool that we can help understand how the financial markets work better and therefore use that in that way?
Quantum will be felt on Wall Street. But can it tip the scales in our favor in Vegas?
You can actually argue the quantum betting will be more fair, because you couldn't really try to look at the qubit without destroying the other qubits. So as soon as you're looking into the quantum betting, people will find out this guy's cheating.
Quantum mechanics is all about probability. So you might be able to determine what the relative probabilities are for you winning or losing, but I think we all know that you mostly lose in Vegas.
While predicting the winner of a horse race may not be in the cards, the odds are in favor of uncovering sustainable solutions for energy, food, fresh water, and the very health of our planet.
Well, my dream is that we can actually make something that's going to benefit society. That's going to solve these big problems that we have today, like climate change.
Imagine creating materials that actually absorb carbon pollution and turn it into energy, just like your ordinary houseplant.
So by 2040, all energy on Earth will be used for computers if we don't change how we're doing computing. It's actually the most finite resource we have. It's more finite than clean water. It's more finite than petroleum. We're absolutely running out. The great news is, unlike with clean water and petroleum, where the solutions are much more complicated, with computing, we have pretty good solutions in mind. One of them is quantum computing. Can we do what plants do naturally and convert, sunlight cheaply and easily and cleanly, no mining, none of that stuff? And yeah, we think we can, right? But we need to understand the quantum part of photosynthesis.
The next time you look at your friendly little ficus, remember it has a PhD in quantum. It likely knows the key to help us solve dozens of challenges we face today that only quantum computing can solve.
How do we get food that is in abundance in some of these places where we have it, be able to transport it in the right ways to the right locations that can get redistributed out to places that need it? And again, those sound like simple problems. They're not. Even as sophisticated as our supercomputers are today, we actually can't solve for that problem.
Or solving the problem of nitrogen fixation, which is how you make artificial fertilizer. So right now, we actually need petroleum as a component of our fertilizer. So we can't stop, extracting petroleum from the earth or we'll actually starve. These are very, very serious problems. And a lot of times people don't know sort of how interconnected they are, like clean water, clean energy, all those things. It's not like, you just put in solar cells and you're done.
Experts predict we will soon reach a new understanding of our universe that will launch an unprecedented revolution of life-changing advancements. And while there are challenging problems to solve, many of us are hoping one of the breakthroughs might be teleportation.
Quantum teleportation is something very different than you think of as than beam me up Scotty, right? One of the rules of quantum mechanics that's very different from the rules of classical information and is the no cloning theory. So that means you can't make an exact copy of a quantum state without destroying the original. So if you have one qubit and you want to make another qubit that's exactly the same, they like to call the process teleportation because it destroys the original, so it's like it moved.
And time travel?
Time travel, I'm not sure. I think you can, in principle, you can't really violate causality, but you can go through wormholes. That's certainly a concept that is scientifically still sound. Maybe you can come out. In fact, that could be the entire universe is entangled.
It's hard to say what fun things will come out, and I'm sure that's what the public would like to know. What we're actually doing right now is solving hard science problems.
Quantum is a new frontier, and with it comes risks and questions of ethics that some fear.
If you build a machine that's smarter than humans, are you worried about that?
With more advanced capabilities that quantum technology brings, we can counteract whatever negative potential there may be.
Every technology brings ethics questions, so there will be negatives. But as long as there's more positives, there's more people interested in working on the positives, it's going to lead to, positive outcomes.
Our mission is to positively change the world through the application of quantum computing. And that positive, that's a big deal. This is a tool. We've created a technology that is a super powerful tool. And tools, as we've seen in the past, can be used for great purposes, and sometimes they can be used for not good purposes. Our job is to make sure that they're only being used for the things that are going to help humanity.
Probability makes one thing abundantly clear. Colorado and its quantum front range make for the ideal quantum state.
There are a lot of challenges in bringing quantum to people's homes, to solving basic problems that we do not yet know the answer for. And for that, a workforce is necessary, a workforce that will work at universities, but also in industry.
The talent that exists in Colorado is outstanding. And part of the reason that talent exists in Colorado to do what we're doing is because of the educational institutions that are here.
We need quantum engineering education programs across the United States, and actually mines and CU Boulder have two of the first in the country. Another reason why Colorado is a real center for this.
Colorado is really situated to make the quantum front range the epicenter of the global quantum computing industry. And so what's now a number of early stage research startups, some work at our great universities like University of Colorado, will soon become a major source of jobs and power the next generation of consumer products across the world.
When you give really smart people tools like this, they get to be very clever. people were making predictions, this is going to be 10 years, 15 years, even from right now until something is useful. Well, we're starting to see evidence that we could be 2 or 3 years away from something that would be utilized for true value creation.
Well, I believe quantum is as big a deal as the internet has been. So if you think about the internet over the last 30 years, that's what quantum is going to be over the next 30 years. When people start to put quantum to work in quantum computing and quantum sensing, what will come of it? We have ideas, but whatever ideas we have now are just scratching the surface of what's going to happen.
I think if we look back on this in 30 years, we're going to be shocked at how little we thought this could do. Shocked.
I would say quantum is the reason I'm hopeful about the future. There's hope that once we can use that technology, we can do things at scale and efficiently like we've never been able to do, and we can start to heal some of those wounds that we've caused.
All in the air around me, information packets are flying over electromagnetic waves. They're bringing data to things like the smartphones that we use all the time. If somebody had a computer or if you had a wearable, what are you going to do? You're going to pick up your smartphone, you're going to look for a picture of a cat on the internet, but they're very cute. Maybe a quantum computer can make one that's even cuter. This is super advanced technology that has become so ubiquitous and so useful and so easy to access that it's boring. When quantum information science is boring too, we'll know we've arrived.